Improved offline optical handwritten character recognition, a comprehensive review using Tensorflow. Abstract. Nowadays, handwritten character recognition, HCR, is a significant and challenging topic of research in the field of image processing. In recent years, extensive research has been conducted on the recognition of handwritten English alphabets. Numerous identification approaches are now being used to recognize handwritten English alphabets, character. HCR's application domain is digital document processing, which includes data mining from data entry, checks, loan applications, credit card applications, tax and health insurance forms, among others. We offer an overview of current research towards the recognition of handwritten English alphabets in this survey. There are no restrictions on the writing technique in a handwritten text. Handwritten alphabets are difficult to recognize due to the wide variety of human handwriting techniques, differences in letter size and shape, and angle. Offline handwritten character recognition will be accomplished in this study utilizing a convolutional neural network and TensorFlow. Offline handwritten text recognition, HTR, systems convert scanned photos containing text to digital text. We will train a neural network, NN, using word images extracted from the IM dataset. Due to the fact that the input layer, and thus all subsequent layers, can be kept short for word images, NN training is possible on the CPU. Of course, a GPU would be better. This implementation satisfies the bare minimal requirements for HTR with TF. Soft Max Regression is used to assign probability to handwritten characters being one of numerous characters since it produces values between 0 and 1 that add to 1. The objective is to design software that is extremely accurate, has a small time and space footprint, and is also ideal in terms of performance. Keywords: handwritten character recognition, neural network, TensorFlow. Problem is the primary constraint: complexity in OCR, typically requiring language-specific approaches. On the other hand, optical character recognition, OCR, of typed articles is in high demand for practical applications such as historical article analysis, official note and article processing, and car plate recognition. OCR, optical character recognition, of written documents for English alphabets has become one of the most successful uses of pattern recognition, PR, and artificial intelligence technologies, AI. Almost majority of the current research in this area is focused on articles that are exceedingly complicated, loud and twisted, as well as improving text recognition rates. Introduction. OCR is a vast area of research in soft computing, artificial intelligence, AI, pattern recognition, PR, and computer vision. OCR is a broad term that refers to the process of digitizing handwritten texts or images of printed materials in order for them to be electronically changed, stored, and searched more effectively and accurately. Despite decades of research and advancements in this area, machines are still far from human-level analysis capabilities. The purpose of an OCR approach is to recognize manuscripts, like humans do, inside a challenging article. OCR techniques are broadly classified into two categories: online text recognition and offline text recognition. Offline OCR is classified into two subcategories: typed text and handwritten text. Offline text recognition is a technique that utilizes a static version of an article to process it. Offline text recognition is divided into two subcategories: typed and handwritten articles. Both subcategories process an image of the article obtained by a scanner or camera. Clearly, given the variety of handwriting styles and the benchmarked nature of handwritings, the offline handwriting identification. 2. Proposed methodology. In the previous sections, we defined the goal and need for this research. Our task requires the employment of a NN.IDAS composed of layers of convolutional neural networks, CNNs, recurrent neural networks, RNNs, and a final connectionist temporal classification, CTC, layer. Additionally, we may see the NN more formally as a function that transfers an image, or matrix, M of size WH to a character sequence, C1, C2, of length 0 to L. As can be seen, the text is recognized on a character-by-character basis, which means that words or texts not included in the training data can be recognized as well, as long as the individual characters get correctly classified.